In this presentation, we will learn how to create a linked list which represents the polynomial. So without any further delay, let's get started. Please note that simply creating a linked list without any order is not a good option at all when the target is to perform some arithmetic operations on it. It is always important for us to understand that simply creating a linked list is not a good choice, and that too a linked list without any order. Because later on we might have to perform some arithmetic operations on it. Actually, those linked lists will represent the polynomials only, right? So it is important to sort the linked list before performing some arithmetic operations on them. We'll see that why in the upcoming lectures, why it is so important to sort the linked list before performing arithmetic operations on them, like addition, subtraction, multiplication, and so on. It would be better if the polynomial expression is sorted in descending order of their exponents. So let us suppose we are available with this polynomial 5x plus 3x square plus 2x cube plus 1. Here you can see the terms are not arranged in this polynomial, right? You can see the first term is 5x, second is 3x square, third is 2x cube. Obviously there is no order here in this case. Now, this is the updated polynomial. Obviously this is the same polynomial, but here you can see that the terms are arranged in descending order of their exponents, right? You can see that the first term is 2x cube in this case, then we have 3x square, then we have 5x to the power 1, then we have 1x to the power 0, right? So you can see that the terms are arranged according to their exponents, and that too in descending order. Let me tell you, this is not a preferred choice, and this is obviously a preferred choice, because we can easily perform operations on these types of polynomials. Fine. So for representing the polynomial expression, we will use a sorted linked list which would be in descending order based on their exponents, right? These polynomial expressions we have to represent with the help of sorted linked lists, and obviously the nodes must be arranged according to their exponent parts, right? And that too in descending order. So let's just try to understand how to create a linked list that will represent a polynomial. And here comes step 1. Step 1 is first things first. Obviously, first we will declare a main function. Everything starts from the main function, right? And here in this main function, as you can see, I have declared a head pointer, and currently this head pointer is holding null. Later on, I just want this head pointer to point to the first node of the linked list. I have declared this head pointer over here in this main function only. This is how this head pointer looks like. Currently it is holding null. After this, I'll simply call this printf function which will print this message on the screen, that is enter the polynomial. And this is how this message looks like in the console window. Enter the polynomial. In this way, the user would be able to know that okay, now I have to add the polynomial, right? Step number 2 is to ask the user to enter the number of terms. This is also a very important step. We must ask the user to enter the number of terms, right? For this purpose, I can declare a variable and then I can print some message on the screen so that user would be able to know that now I have to add the number of terms, and then we can accept the input with the help of scanf function and then put that value in the variable itself. I can do all that procedure in this main function, but the better option is to create a separate function for doing all these things. And obviously not only these things, later on we will ask the user to enter the terms, right? Obviously after asking the number of terms, we must ask the user to enter the terms. Instead of writing everything in the main function, the best option is to create a separate function. Here in this case, I am going to create a separate function called create. And to this create function, here you can see, I am passing head pointer, and I just want that this particular function will give me the address of the first node of the linked list, which is created by this particular function, right? So now we will shift everything to the create function. And here you can see that this is how our create function looks like. Here you can see this create function is receiving the head pointer, which means that it is receiving null. After this, I'm just creating a separate variable called n, and this is how this variable looks like. And after this, I'm asking the user to enter the number of terms with the help of this printf function. So this message will get simply printed on the screen, that is enter the number of terms. After this, with the help of scanf function, I will receive the input from the user and will store that input, that particular value inside this variable n. Let us suppose that user has entered 2, so I'll simply store that value inside this n variable. And this is only possible with the help of scanf function. Now, what is the next step? Next step is to ask the user to enter the terms. This means ask the user to enter the coefficient and exponent of the terms. Obviously, a term is composed of coefficient, variable and exponent. There is no need of variable because variable is fixed. But coefficient and exponent is required every time. So let me just ask the user to enter the coefficient and exponent of the terms. For this purpose, I have declared here a variable I. This is an iterator. I need an iterator because I want to run a for loop, right? So variable I is required. So let me just show this variable I over here. After this, I just want to create a separate variable for storing coefficient, right? And this is how coef variable looks like. And after this, I just want to create an expo variable for storing the exponent, right? And this is how expo variable looks like. This will store the exponent and this will store the coefficient. And this is an iterator. And this is our for loop, which will run from 0 to n minus 1, right? Let's just focus on this particular piece of code. That is for I equal to 0, I less than n, I plus plus. We already know how for loop works. First, the initialization step will occur. That is, first the I is initialized with 0. So I is initialized with 0. After this, we will check this condition. Is 0 less than n? Obviously 0 is less than n. Currently you can see that n is holding 2. You can see this over here that n is holding 2. So obviously we will replace this n by 2. This means that we are checking this condition is I less than 2. Obviously you can see that I is 0 and 0 is less than 2. So this condition is satisfied, right? Why I'm putting 2 over here? Because I want to run this loop from 0 to 1. Or I just want to run this loop 2 times, right? And in this loop, you can see that I'm calling this printf function enter the coefficient for term %d, which means enter the coefficient for term I plus 1. In other words, enter the coefficient for term 1. I'll simply ask the user to enter the coefficient for term 1. After this scanf function is called, and obviously this means that I'm asking the user to enter some value. And here in this case, let's say user has entered 3. So this 3 will get stored over here in this coef variable. As you can see in the scanf function, I'm putting this over here, that is %f, and then after this ampersand coef, right? Which means that I just want to store this particular value inside coef variable. Then after this, the next step is to ask the user to enter the exponent for term 1. So let me just print this message over here. Enter the exponent for term 1. This message will get printed on the screen. This means that now user would be able to see this message, and obviously he or she would be able to get that, okay, now I have to add the exponent for term 1. With the help of scanf function, I will accept the input from the user and will simply store that value inside this expo variable, right? So you can see that coef is right now holding value 3 and expo is holding 2. So coefficient of the first term is 3 and the exponent of the first term is 2. This is what it means. Now you can clearly understand why I'm running this loop, because I have to ask this whole thing, that is coefficient and exponent for each term. User has entered 2 over here, which means that user want to enter 2 terms. This means I have to ask this twice. Enter the coefficient for term 1, enter the exponent for term 1, then enter the coefficient for term 2, enter the exponent for term 2, and this goes on in this way, right? Currently this value is 2, which means that this whole thing will get printed twice, right? What is the next step? We have the coefficient and the exponent of the first term of the polynomial. Isn't that so? Now we have the coefficient, we have the exponent of the first term of the polynomial. It's time for step 4. In step 4, we will simply insert the new node in the sorted linked list. This is what this step does. It simply allows us to create a new node in the sorted linked list. For this purpose, I will simply call this insert function, and you can see the argument list of this insert function. Here you can see the first argument is head, second argument is coef, and third argument is expo. Obviously these 2 arguments are mandatory and this argument is also mandatory, right? Here to this insert function, I am simply passing head. Head is currently holding null. I just want that this insert function will return the address of the first node of the linked list, right? So it's time to consider this insert function. This is the insert function from the lecture sorted singly linked list. This is that insert function. You are already aware about how to create a sorted singly linked list. That's what we're going to do here as well. In the case of simple sorted singly linked list, we have a data part and we have the link part. But here in this case, we have the coefficient part, exponent part and the link part. So new node must have all these three components, right? This is the first requirement. Second thing, you can see that I have declared a key variable over here and currently it is holding data. That is the data part of the new node. And here I'm checking this condition if head is equal to null or key is less than head data. If this key is less than head data, which means that I'm asking, is the data of the new node is less than the data of the first node? If it is the case, then we will simply add this new node in front of the head. That is the first node of the linked list. This is what this piece of code will do. And if at all it is the case that head is not null and key is not less than head data, then this else part will get evaluated. Which means that we will simply traverse the list until we will find that position where key is actually less than the data part of the node. If somewhere we have found out that key is less than the data part of the node, we will simply insert the new node before that node, right? And that is what this piece of code will do. If you have any doubt about this function, then I would recommend you to watch this lecture before moving further. Now let's see this new insert function. There are some changes I have made in this function. First of all, you can see that we have coefficient part and the exponent part as well in our singly linked list. And obviously we have a link part, right? Then this piece of code is same as this piece of code, but there is one little change. Here instead of key, we have the x part, that is exponent of the new node. And I'm comparing it with the exponent of the head node, right? That is the first node of the linked list. And here obviously the sign is greater than instead of less than, because I want to arrange the linked list in descending order of their exponents. This depends on the exponents, right? Not on the coefficients. So here in this case, this condition needs to be checked that if x is greater than head expo, this means that if the exponent of the new node is greater than the exponent of the first node, then we will insert the new node in front of that node. In this way, we would be able to maintain the descending order, right? After this, if at all it is the case that head is not null and the exponent of the new node is not greater than the exponent of the head, then we will move to the else part. Again, we will compare the exponent of the new node with the exponents of the other nodes. And if we would be able to find that the exponent of the new node is greater than the exponent of the node, then we will insert the new node in front of that particular node. Right? This means that we will insert this new node in front of the node whose exponent is actually less than the exponent of this new node. Fine. This piece of code will take care of that. Right? Here you can see instead of less than sign, we have greater than sign. And obviously key must be replaced by x. And everything else is exactly the same. Nothing is changed apart from this. Right? The logic of the code is same. Now, let's just evaluate this code. You can see that this head pointer will receive null, this coefficient will receive 3 and exponent will receive 2. There's no doubt about this. After this, this piece of code will get evaluated, which will simply create a new node. Let us suppose that the address of this new node is 1000 and obviously the coefficient part of this node is holding 3 and the exponent part is holding 2. You can see that here it is 3 and here it is 2, right? That is why 3 must come over here and 2 must come over here. And obviously the link part of this node must be null, right? You can see that new p link is null. Now this new p is actually pointing to this particular node, right? There must be some pointer which must point to the node. Otherwise there is no way we would be able to access this node, right? After this piece of code will get evaluated, which means we will check this condition if head is equal to null or exponent of the new node is greater than the head expo, then we will evaluate this piece of code. Right now you can see that head is null, which means that this condition is satisfied. So we'll execute this piece of code, that is new p link equals to head. New p link equals to head means this will get replaced by null only, and head is equal to new p means that head is now updated by the address 1000 and this means that head is now pointing to this particular node, which simply means that this is our first node of the linked list, right? After this, obviously head will get returned back to the function and here this head will receive the address 1000. Isn't that so? After this, I will get incremented, which means that this 0 will get replaced by 1 and obviously we will again check this condition is 1 less than 2. Obviously 1 is less than 2, right? So we'll get inside this for loop. First, this message will get printed, enter the coefficient for term 2. Obviously, I is 1 right now, so this will get replaced by 2. And eventually, this percentage D will get replaced by 2. So this message will get printed on the screen. That is, enter the coefficient for term 2. After this, with the help of scanf function, we will receive this value 5, which is entered by the user over here, right? We'll simply store that value in this coef variable. And then after this, with the help of this printf function, again, we will ask the user to enter the exponent for term 2. And then after this, with the help of scanf function, we will be able to receive the exponent entered by the user in this particular variable, right? And then the insert function is called. Now let's see the insert function once again. Here in this case, obviously the coefficient is 5 and exponent is 1, right? Let me just evaluate this piece of code. This means we'll create a new node and the address of this node is 2000. And obviously this time new p pointer is pointing to this particular node. Here you can see this particular node has the coefficient 5 and the exponent 1, as co is containing 5 and x is containing 1. After this piece of code will not get evaluated because head is not null and the exponent part of this node is not greater than the exponent part of the first node, right? Therefore, this piece of code will not get evaluated. Hence, the else part will get evaluated. This means that temp is updated by head. You can see that I have declared a temp pointer over here. This temp pointer is required for the traversal, right? So temp is updated by head, which means that now temp is holding this address 1000. After this, while loop will get evaluated. You can see that temp link is equal to null. Therefore, this piece of code will not get evaluated because this condition is not satisfied, right? After this, we have this piece of code, that is new p link equal to temp link equal to new p. First, we will update the link part of this node by temp link. Temp link is null, so this will get updated by null only. After this, temp link will get updated by new p, which means that this link part will get updated by the address 2000. And this simply means that now this node is pointing to this particular node, right? This means that this is the first node of the linked list and this is the second node of the linked list. And you can see the order is maintained. Descending order is maintained, right? Here you can see the first exponent is 2 and the second exponent is 1. And finally, we will return head back to the function, that is the address of the first node, which is 1000. This means we are simply passing the polynomial, right? This head will receive that address and again we will increment I by 1. Here this will get replaced by 2 and then we'll check this condition. Is 2 less than 2? Obviously not. So we'll get outside of this for loop. And now we'll simply return head back to the main function. And simply this head pointer will receive that address 1000, which means that we have received the complete linked list, right? Receiving the address of the first node of the linked list means that we have received the complete linked list. Isn't that so? We are already aware about this. Now, obviously, the final step is to print the polynomial. So let me just print the polynomial with the help of this print function. Okay. This print function is capable of printing the complete polynomial. Now, this is not a printf function. This is a print function. This function is created by me. So let us see how this function works. In this print function, you can see the parameter is struct node star head. Obviously, this head pointer will receive this address 1000 from the main function. And this means that this function has received the complete linked list. First, we are checking this condition. Is head equal to null? You can see that head is not null. Therefore, this message will not get printed on the screen. This means that else part will get evaluated. You can clearly see that temp pointer is updated by head, which means that our temp pointer will hold 1000 address. This temp pointer is required for traversal. After this, we'll check this condition in the while loop. Is temp equal to null? You can clearly see that temp is not null. So we'll get inside this while loop and we will print this message on the screen in these quotes, right? Here you can see this message will get printed on the screen. First, this round bracket will get printed. Then we have this %.1f, which simply means that I want to print my coefficient. Obviously, this is the placeholder for this coefficient, right? I just want to print my coefficient up to 1 decimal point. This is what this statement means. %.1f will print the coefficient up to 1 decimal point. And then after this, variable x will get printed. Then this power symbol will get printed. And then this %d will get replaced by temp expo, which means the exponent part of this particular node will also get printed on the screen. And finally, this closing bracket, right? This is how the output looks like. 3.0x to the power 2. This is the first term of the polynomial. Isn't that so? 3.0 represents the coefficient and this 2 represents the exponent, right? After this, temp is updated by temp link, which means that temp is now pointing to the second node of the linked list. And then we will check this condition, is temp equal to null? Obviously temp is not null, therefore print plus. So plus will get printed after this. Obviously, after printing the term, we must print plus. We must check this. If temp equal to null, then we will not print plus. We will print \n. That means new line. If temp is not equal to null, then we will print plus. Here you can see temp is not null, therefore plus will get printed on the screen. After this, obviously this piece of code will again get evaluated, which means we'll check this condition, is temp equal to null. Right now temp is not null. So again this printf function will print the term. Here in this case the coefficient is 5 and exponent is 1. So this will get printed on the screen, that is 5.0x to the power 1, right? After this temp will get updated by temp link. Temp link is null, therefore temp is updated by null. And then after this, we will check this condition, is temp not equal to null? No. Else part will get evaluated, which means that \n will get printed on the screen. And that's it. This is the resultant polynomial so obtained, right? From this linked list, we would be able to print the polynomial easily with the help of this print function. Now let me just show the complete code in code blocks. Here you can see first struct node is declared, then we have this insert function which will insert the new node, obviously maintaining the order as well. After this we have this create function, then we have this print function, then we have this main function, right? Let me just execute this code. It is asking us to enter the polynomial, then it is asking us to enter the number of terms. Let's say I want to enter 3 terms. First it is asking us to enter the coefficient for term 1. Let's say I enter 5. After this, it is asking us to enter the exponent for term 1. Let's say I enter 6. Then it is asking us to enter the coefficient for term 2. Let's say this is 43. Then enter the exponent for term 2. Let's say it is 2. After this, it is asking us to enter the coefficient for term 3. I will enter 23. And the exponent of term 3, let's say 7. This is how the resultant polynomial looks like. 23.0x to the power 7. Plus 5.0x to the power 6 plus 43.0x to the power 2. Isn't that correct? Obviously you can see that the order is maintained. You can see the terms are sorted properly according to their exponents, right? They are sorted in descending order. You can see 7 comes first, then 6 and then 2, right? So in this way we would be able to print the complete polynomial in descending order of their exponents. Okay friends, this is it for now. Thank you for watching this presentation.